Hi, my name is James Blair. I am part of the team that runs the developer infrastructure for the OpenStack project. I'm not the person who was originally listed on this schedule. That was Monty Taylor, who also helps run that team. And he was called away to do something I assume is very, very important. So he titled the talk in this slot ZoolU, and I don't know if that was intended to be an expletive or not. I wrote a program called Zool, and I'm not sure really what he was trying to say with that talk. But at any rate, I'm going to give a talk with some very similar content about how we do continuous integration and how we run the developer infrastructure for the OpenStack project, which of course is the answer to something that was kept coming up in the previous talk, which is the infinite number of tests that one might want to run. You should run an infinite number of tests, and you should do them on a public cloud, particularly if you can convince that public cloud provider to give you resources for free, which is what we've managed to do. So I'm not going to talk about OpenStack itself. There are several other talks at this conference where you can learn about some of the components of OpenStack. So while I'm not going to talk about OpenStack, let me tell you about OpenStack real quick. It's open source software for running public and private clouds. Think Rackspace public cloud, HP public cloud. They're all running OpenStack. You can download the software yourself, run it on your laptop or the server farm that you run in your basement, as some of the people on our team do, or inside your own Fortune 500 company or whatever it is that you're doing. It's all the same software, same APIs. That's sort of the value proposition there. And of course, that being the case, we try to eat our own dog food. So all of the infrastructure that we do for CI is run on currently 2 public OpenStack clouds. So it's actually, we see it as a massive cross-cloud single application. But a lot of what we do is driven by the complexity of OpenStack itself. I'm going to refer to it a lot as a single project, and that's the way a lot of us like to think of it. But it's really composed of a lot of individual software components, which are their own projects led by their own groups of people with their own groups of developers, their own Git repositories and everything. So on the left, we have all of the servers that do things that you might want to do in a cloud, manage compute systems, storage systems, things like that. Over on the right, under the arrow, which indicates that they're very important, are the Python or the client libraries. You'll notice that they're all in Python. OpenStack itself is all written in Python, and so actually that's going to drive a bit of some of the decisions and some of the tooling that I'm going to talk about in a minute. Really quickly, there's, with a project of this scale, there are a number of horizontal efforts and programs. There's a documentation team. There's a team that was formed specifically to identify bits of code that kept getting copied around to the other programs and refactor those out into separate libraries. There's a quality assurance team, basically a team that they don't do what a QA team would normally do, which is sit there and run tests all the time. What they do is they try to make sure that all of the tests that other people are writing are working correctly, and when things go wrong, they help triage them. So the testing infrastructure here is large enough that while we expect every developer to write and deal with the consequences of testing their own code, we still need a team to sort of coordinate that effort, and that's what the QA team is for. There's release management, translations, vulnerability management, and of course the infrastructure team, which runs all of the things that I'm going to talk about here. The release management process, it impacts a little bit of what we do. I'm not going to go into it in very much detail, but basically you need to know that we're on a 6-month timed release cadence. We make sure that the tip of master is always runnable. There's actually a group of folks that are really interested in doing continuous deployment of OpenStack. But we also, every 6 months, we fork off a stable branch, and we maintain that for a while with the help of the major Linux distributions. So I mentioned a project of this scale. Here's a little bit about that scale. We have contributors from a number of major companies. A lot of people who work on OpenStack are actually employed to work on OpenStack. So as an open source project, that means it's a little bit different than your kind of weekend hacking sort of project. But you can see some of the companies that are represented up there. This is changing all the time. This is a snapshot from a little while ago, but it's fairly representative of the kind of diversity that we get. We have Red Hat and HP and IBM all collaborating on the software, which is pretty cool. But there's with that means that we have teams working in groups in these separate companies all over the world. So as a project, one of the things that we have to do is to try to unify these teams and help these people work together as if they were all on the same team.
Do you get these corporate contributors trying to drag the project in different directions?
Not really. I think. So one of the things that we do is we have the design summit every 6 months, and we get everybody in the room. And when somebody, that really helps a lot with, like, I want this component to go in this direction. I want it to go this other one. So get everybody on the same page and hash that sort of thing out, so that you know what you're going to be doing in the next 6 months. So that's worked pretty well. There are some OpenStack developers here in the room, and if they disagree with that answer, feel free to object.
I would just say that there is a different flavor based on the project. I think that there's a really nice continuity in infrastructure in terms of everybody's going in the same direction, and that every project has its own kind of contribution.
Yeah, that's a good point. Since you've been doing so much work with the Neutron project, some of the projects are more open to different kinds of architectures. For instance, the Neutron, the networking as a service project, it has to deal with all of these different companies, all of their different equipments. It actually has to talk to lots of different switches, which means lots of plugins for different components. So in that project in particular, there's a huge amount of people working on their particular area. And so one of the challenges that we've been working with is how do we get, in a project that facilitates and is so geared towards that, how do we get those people on the same page? And
I think it's no worse than the kernel. In fact, maybe it's a bit better, because for each project, the group of people with the approval rubber stamp is more than one person. And so those people have to reach a consensus about what goes in. So you do occasionally see stuff that would hurt everybody but one person. It's not normally intentional. It's, well, I haven't thought about your use case because I work for VMware.
yeah.
But then when you say, well, you know what, your code's not merging, people tend to come around and make it more generic or whatever.
Yeah, and that's a really good point, which I'm really hoping segues into these next couple of slides, which is sort of some of the tooling and the process that we have around actually testing and merging code. So to try to get everybody on the same page, we tried to do development of tooling around development, essentially. When we have tools to help get your code into the code review system, we have tools around setting up a test OpenStack system in order to do development to tests and things like that. We try to do that all centrally so that people aren't sort of off in their corner working on cool little tools that actually everybody needs. But that kind of helps get people treating this as as a project and a unified global team when the onboarding process for a new developer is the same. So no matter what company that you're working with, in order to contribute code to the process, to the project, you're going to use the same process and the same tools and things like that. And so one of the things that we do is to try to make that that process simple for everybody, no matter where they're coming from. And to elaborate a little bit on one of the things Michael was getting at, which is the code review process. It's very important to what we do, and customarily, every patch needs to have a sign-off from at least 2 core reviewers on the team. And the core review team is actually maintaining and growing that is seen as a really important activity for the project. So core reviewers need to identify potential new core reviewers and help bring them into the team and things like that. And so with this team that's made up of people from, again, lots of different companies working on it, I think that really helps as well. So this is the set of developer infrastructure that we run, at least as of the last time we updated this slide. There's obviously a lot of this stuff, especially up in the top left-hand corner, is square on into the subject of this mini-conf. It's all about developer, about continuous integration and things like that. But we see a lot of these systems as integrated too. Even if they're a little further away from continuous integration proper. How we actually integrate our code review system with our bug tracking system and things like that are all actually very important when you start treating this as a whole. So everything that we do related to all of those systems is run out of a single Puppet repository that's in Git and is publicly accessible. And we actually run the operations of the project developer infrastructure in the same way as the project itself. So again, every change goes through code review. A couple people have to sign off on it at least. Anybody can propose a change. If you propose a change to start running a new piece of software on a server, when we approve that change, it will just happen. If you propose a change to spin up a new server, well, one of us will type in the commands to spin up the new server. But at any rate, it does all go through code review. It is all public, and that's actually pretty cool. Cool enough that Elizabeth is giving a talk on that on Wednesday here at LCA. So if you want to dive into the mechanics of how we're doing that, I would encourage you to attend that talk. So as I mentioned earlier, the development environment for OpenStack is in Python. Currently everything in OpenStack is a Python program. So a lot of our testing and a lot of our developer infrastructure is sort of based around that. There are some of the specifics if you're interested if you've got a Python project. We've found it useful to target a couple of specific operating system variants. We follow the PEP 8 standard of the Python style guide, which actually turns out to be pretty important once you have about 300 active developers all hacking on a project at the same time. Things like indentation and whether you use spaces or tabs and where you put your parentheses actually becomes really important. We have a whole bunch of IRC channels. We have general development channels. We have 2 meeting channels at this point, actually, that are pretty much booked solid. So you can just join OpenStack meeting at any time of day, and there will be some kind of official meeting for some project going on. But that's part of how we run the governance of the project in a really open manner. And of course, we run tests on newly contributed changes, which is what we're really interested in here. So we do this thing called project gating, where we don't let a change land to a branch. unless it passes all of the tests that we have for that project, or all of the projects even. So of course, as a developer, it's a really good idea to run tests after you write some code. We don't necessarily trust that everybody's going to do that. Again, with so many developers, it's nice to have computers do this for us. But also, it's gotten to a point where running the tests for OpenStack is actually quite complicated. You can imagine that spinning up a cloud computing fabric controller and running all of the integration test suite for that might be a little bit complicated. If you do it, it will consume a machine and you'll have to throw it away and never use it again. Again, that's a really good use of a cloud. So what we do is we, for every change, we spin up a complete OpenStack instance, run all of the integration tests on it, which take about 40 minutes. And we do that several times for several different configurations. So we actually, I think a change to Nova will I don't know, spin up about 5 or 6 something full OpenStack clouds, and then we have a bunch of other tests that like unit tests and style guide tests and things like that that also run on them. So anyway, the reason we do this is to basically facilitate collaboration among all of these developers, and to make sure that the process is egalitarian. Going back again to if people wanting to take it in their own direction, if nobody's exempted from this process, nobody can push a change into Git without it passing these tests. Nobody says, "Oh, I'm pretty sure it'll work. I'll just Git push it." That never happens here. So everybody's subjected to the same process. And as a developer, it's really handy because it means that when you start your day, you can check out the latest copy of the code, and that it's still passing tests at least. It's that somebody didn't break it right before they went to bed yesterday, and that's so that's generally not the first thing that you're going to have to deal with in the morning, is fixing somebody else's code. So just here's a peek at our status screen for Zool, which drives a lot of our project automation. It's titled "Everything is Automated" because this kind of gives you an idea of all of the different kinds of things we're doing. Over here on the left in the check pipeline is every time somebody uploads a change, it starts running tests for those changes. So here's a change to Nova, and it's running all of these jobs for that change. Over here in the gate, that's the project gating system that I was telling you about. It's people are actually trying to merge changes here, and so once again we run tests on those, and if they pass, then these changes are going to merge. But we also do a lot of other project automation through the same system. We build tarballs, run coverage jobs, build documentations. We build our release artifacts. We do translation, imports and exports and things like that, all through this system as well. And I'm going to get into a little bit more about that later. So the process for a developer is pretty simple, but it's kind of specific. You clone a copy of a repository, you make some changes in your local environment, and commit those changes. You push it to our code review system called Garrett, using a tool that we wrote called Git Review. So that's actually kind of cool because it's just one command. You git commit and then git review, and it pushes it up for code review. So once it shows up in Garrett, Jenkins starts running tests on it. And when somebody, reviewers come along and they review your change, and if they like it, they approve it for merging, and it goes back to Jenkins, and if it passes tests, it gets merged into the Git repository. So one of the reasons that we run, you'll notice Jenkins is on here twice. One of the reasons that we run tests not only on upload, that's to try to get the test results in front of reviewers as quickly as possible. But we also do it right before merging because we have a lot of components, if you remember from that first slide, and they all relate to each other, and they're all moving very quickly. So even if your change passed tests when you uploaded it, something may have changed in either this project or some other project since then, and so we make sure to run that test again before we actually merge it. The code review system that we use is called Garrett. It is developed by Google for the Android open source project. It's a standalone patch review system, and one of the neat things about it is it has a lot of points that you can hook into for automation. You can do queries against it to get JSON information back. You can subscribe to an event stream and respond to things in real time. It can run hooks, like get hooks internally when somebody uploads something or it's merged. It has extensible code review categories. So in general, it's just really flexible and adaptable to a lot of systems, which is why we've been able to hook it into all of those things that we run. Here's a screenshot of a typical review in Garrett. So when somebody goes to review a change, they can come and they can see the git commit message on the right. Over here at the bottom are the votes from other reviewers. So this change was fairly positively received. There's a side-by-side diff view, which works out really well for actually tracking down, actually seeing what's changed. And you can do, it's not shown here, but you can do inline comments, line-by-line comments. So we have Garrett hooked up to Launchpad, which we use for bug tracking. And you'll note here's an example of when somebody proposed to change to Garrett, our system automatically updated the bug in Launchpad and left a link back to Garrett saying, hey, somebody's attempting to fix this bug, at least. And so that sort of facilitates people finding new information about things when they're going and looking at bugs. Here's a screenshot of reviews that's slightly cut off here, but you can see that Garrett has some sort of dashboard screens where you can see all of the reviews that have been approved or are awaiting review or things like that. It's actually pretty good for managing a workflow around development. And I mentioned Git review earlier. Here's what this looks like for a developer. If you commit a change, git commit obviously right there, and then you just type git review and it pushes it up to Garrett for review. And once you start using a system like this, it's really hard for me to use anything else now because just the idea that I can write some code and type this one command and it's all for review. Then I could go write some more code is really attractive.
So when does the push happen?
Git review does the push. So honestly, if you're familiar with Git, it's a very simple around git push Garrett head : refs for master. But we didn't want to tell 1,000 developers to type that, so instead we wrote git review. It does a few more things. It's a zero configuration kind of system where by looking at a .git review in the Git repository, it will know what Garrett server needs to be pushed to, and so it'll automatically configure the Git remote for that Garrett server and things like that. Yeah, so basically that one command is designed to do everything needed to interact with Garrett. With no advanced preparation other than downloading and installing Git review, which is in Debian and Ubuntu and Fedora. So you can package manager install that for whatever distro you have.
We use a similar command to make push, and then it actually just even goes through Jenkins first and has some generic checks. So if you're not adhering to certain things, then it doesn't even push it up to Garrett.
That's a really, what project is that?
That's not.
Okay, that's a really clever idea. We don't reject the pushes based on failures. We just try to to get them into the system and start running the tests on them as quickly as possible. I think most developers at this point, or sorry, most reviewers at this point, probably just wait for those initial results to come back positive before they'll really even start looking at a review at this point. So we run a couple of different kinds of tests. You can imagine we run unit tests, integration tests, things like that, different levels of complexity. One of the things that I sort of glossed over earlier is when we're doing the project gating of changes, we're not just testing this change. What we're trying to do is test the final effect of this change. What we're doing is testing when after this change lands, is the project still going to work? Which is a simple but subtle thing, especially when you start thinking about the idea that you might have a bunch of changes in flight. So we need to test that when all of those changes land, is the project still going to work? Things like that. Let's see. So we actually have a script called Garrett Git Prep, which does this for us. It depending on what the proposed future state of the project is, Garrett Git Prep will download all of the it'll check out all of the Git repositories to the appropriate locations, and then we can install from there.
Is that where the rebase happens as well?
The rebase?
So occasionally you see a review that says, look, I couldn't rebase this against the current
Oh.
state of master. Where's that?
That actually comes from Zool. That's Zool's attempt to merge that change into master.
So the ref that comes out of Zool is post rebase?
Yes, or merge or whatever, but yes. So we have this thing called DevStack Gate. It's based on DevStack, which is a system that's it's basically a series of shell scripts that set up all of the OpenStack components needed to run a cloud, and it's how we set up all of those components and run the integrated test suite. A couple of the problems that we run into with DevStack are related to sort of the number of test runs that we do. We run tens of thousands of these every day, and it turns out that when you start doing that, relying on external services like PyPy or mirrors or things like that, they can fail a lot. So one of the things that we do is we have a system called Node Pool, which will it'll take a cloud node, it'll install all of the dependencies needed for us to run our tests. It'll snapshot that, and then it spins up test nodes on demand so that we can run our Jenkins tests on them. And all of those nodes are based on those on that snapshot, so that everything's sort of pre-cached. The engine that drives all of this automation is called Zool. It's a general purpose project gating and project automation system. It's another piece of software that we wrote within the OpenStack infrastructure project. It interfaces with Garrett and it says Jenkins, but at this point it's anything else you might want to interface it with. There's at least one person in this room who has something that's not Jenkins running tests that's integrated with Zool. It's really flexible. It's all configuration driven. And it does this sort of mind-bending thing, which is it tests a serialized queue of changes in parallel. And I don't have time to get into how that works at this talk, but on Friday at 10:40, I'm giving a talk on that that focuses more closely on Zool itself. So these are the things that I'm going to skip over and talk about at that other talk. So we have, I think at last count, do you remember how many? We have many, many hundreds of jobs in Jenkins at this point. And around the time that we had about 80 jobs in Jenkins, and we were managing them by going through the web interface and clicking on things a lot. Around the time we had 80 of those, we said this isn't going to work in the long run. And so we started writing a program called Jenkins Job Builder. And it takes, we're really good at names. It takes YAML files that we keep in a Git repository, and it translates those into the XML that Jenkins uses. And it's got a lot of templating system built into it. So we can do things like say, here are all of the jobs that a Python project needs to have, and now instantiate all of those jobs for this Python project and this other Python project and this other one. And so, with the combinatorials on that, we end up with many hundreds of jobs, but they're very easily managed because they're all human-readable YAML files in Git. And of course, again, anybody can propose changes to them. Here's a quick example of a template in Jenkins Job Builder. So if you wanted to run a PEP8 job, that's the Python style checker, you could say the name of this job is Gate, insert name of project here, PEP8. Run git prep to set up the Git repository, then run the PEP8 builder, which is defined elsewhere. Anyway, a lot of our actual configuration looks nearly this simple, and so it's really been able to help us scale that out, as well as make it more accessible for anybody to help pitch in and maintain this stuff. So if we had that template and we wanted to apply it to the Nova project, that's what it would look like. Another really interesting thing that we've been doing is, again, because we run so many test jobs for so many projects, we have all of those test runs generate quite a bit of log data. And so we've actually been dealing with the challenge of how do we present that to developers? When there's a failed test run for this massively complex system, how do we say, okay, here are the logs, figure out what happened? And so we started by uploading them all to an Apache web server and said, here are the logs, figure out what happened. And being as there's 250 megs of them for a single 40-minute, compressed. 250 megs compressed in a single 40-minute test run. That didn't go over very well. So Clark Boylan, who's here and also going to be talking about this on Wednesday, I believe. Friday? Drat, did I get it wrong? I think it is Friday. Sorry. Clark's going to be talking about this on Friday. He's been leading a lot of the development in this area, which is around how do we present these logs to users. So we're doing things like taking all of the logs from all of the test runs, putting them through Logstash, so that you can use Kibana to search through them. We can do Elasticsearch queries against the logs and say things like, well, when did this error message start appearing? And things like that. So it's been really useful, and it's actually, I think, a really interesting area of development. Finally, while we try to do a lot of this testing in the context of the OpenStack project infrastructure, which, as I mentioned, anybody can contribute and help out with. Sometimes that's just not feasible. We run all of our stuff on public clouds, which means that if you wanted to test how Neutron integrates with some Cisco router, we're not going to be able to test that. You're going to have to do that in a lab somewhere. And so we have a formalized system around third-party testing where developers can subscribe to the Garrett event stream. They get notified of new changes. They can run them on their own test rigs in-house and report the results back to Garrett. And then that way developers can see like, oh, well, this change broke Cisco switches. And then, we're not gating on that, so you can decide whether or not you actually care if you broke a Cisco switch or not. But the information is there. And Michael Still is one of the folks in our community who's doing this. He's specifically doing it around database migrations, basically because he wants to test with production information, and he doesn't want to do that by checking in the production information into a public Git repository. Anyway, he'll be talking about that Wednesday, I'm hoping.
Yeah, in the afternoon sometime.
Yeah. So anyway, hopefully you can attend that one too. These slides, as well as many others, are all kept in a public Git repository that goes through code review and is automatically published through Zool. And you can see them at docs.openstack.org info publications. And do I have any time for questions?
About 54 seconds.
All right. Yes.
So you mentioned that you have integration tests that take like 40 minutes to run.
Yes.
So we've had the policy that if your test takes longer than a minute or so, it's probably too slow, and our developers don't want to wait more than 2 or 3 minutes to get an up or down for Jenkins. How do you guys even deal process-wise with the fact that it takes like an hour before you know whether what you did even worked?
Work on lots of, to repeat the question. So the question was, hey, if your tests take 40 minutes, why do your developers even put up with that, to paraphrase. One of the coping strategies for that is to have lots of things going on at once. So push something up for testing, switch to work on something else, and you get your results back later. Another thing is the unit tests can be run locally very easily and much faster than that. So of course, you can run the unit tests for a project just on your workstation, and that should work fine and be fairly quick, especially if you do something like filter it down to just the tests in the area that you're working on.
So unit tests are parallel?
Plus the unit tests, thanks to this guy over here, can be run in parallel. We use test repository for most of the projects at this point. I think it's still an ongoing.
Nice and swift.
Yeah.
There's a text set for one and half of one for the other.
Right. But then just going back to integration testing, one of the things that we're doing with that is we are spinning up an entire cloud. So there's a good 10 minutes of just installing the software before we even start doing the tests. Honestly, given all that overhead, a lot of developers are pretty happy with the idea that they don't even have to worry about that at all, and that in only 40 minutes, this automated system will do all that for them and get the results back to them. But then again, if you are actually doing development, it's likely that you might be doing it inside of your own copy of DevStack that already has a cloud spun up, right? So you might even be doing iterative development where you're editing a file and you start up the process and run it again and that. And if you're in that context, you can run the integration tests locally as well. And again, using test repository, they run in parallel, and they're actually pretty fast if you narrow it down. So if you're down there in the trenches, you can run an individual test locally on your own system, and it should only take a couple of seconds.
I think the other thing too there is the thing with Zool is at the end of those 40 minutes, it will not only hit +2 with action measure. So if it passes,
Yeah, we have the same thing, except people use Zool as a service to service their own laziness. Because if all you're running in Zool is like, JS hint and documentation building and a couple other things, then it takes 2 minutes to run it all. And people just like submit code blindly without even running tests locally.
Yeah.
And then 2 minutes later, it comes back, well, this one unit test failed, and you put a wrong comment here, and then they go, oh, they submitted that minute thing, they fix it, and then 2 minutes later, they get.
Yeah, we used to get sort of frustrated with people like that who would waste the test resources on something that they could have run locally, and we're like, hey, why are you so lazy? But then once the integration tests started taking 40 minutes to run, and the full suite of unit tests for Nova, I think takes around 10 minutes or 15 or something at this point. We lost that argument, and now we're happy to provide this public service, which will run these tests for you. Because hey, at least you're running tests. So.
Cool. We should wrap it up.
All right. Thank you.